Hello and welcome to the integumentary system. Now the integumentary system is essentially skin plus the accessory organs that we find in skin, but we can't just talk about skin because there are other things in an organ system. Remember, an organ system is more than one organ, and skin, the biggest organ in the body, is just one organ. So you have to have other organs there as well, such as the sweat glands, etc. Count as that. Alright, so we're going to do this in two parts. Because skin essentially has two main layers. It has the epidermis and it has the dermis. So the epidermis is up on the surface of the skin, the dermis sits below that. So in this first part we're going to think about properties of the integumentary system, and then we're going to think about the epidermal layer and how many layers are there, or strata are there, and what we find in there. Alright, so first of all we're going to think about properties. Now I've written up just a few properties here that the integumentary system is responsible for. So the first and rather obvious one is our skin creates a barrier to the outside world. The skin on the outside, the cells on the outside of our skin are dead cells, so there's not a lot of nutrition in them for bacteria or even viruses to get a hold of. So it makes a good, thick, tough barrier, which prevents most of the pathogens that would like to get inside and get to our blood and get into all the nutrients, etc. of the cells. It keeps them out. So protection. So it's part of the immune system. Water balance. We'll see that when we look at the dermal layer in the next short video lecture, that a large part of the dermal layer is made up of irregular connective tissue, dense irregular tissue. Now if you remember, that is essentially collagen fibers, which are not necessarily all lined up like that as a ligament would be. They're kind of set at angles, but they're very, very tough, and they hold the skin down onto the layers below. Now one of the things about collagen is it's a protein. It's three proteins wrapped around each other, and these proteins have a lot of charge on them. Now if you remember back to properties of water, earlier in the Essentials course, or if you're doing anatomy then from physiology, water is also carrying a slight charge on it. So water acts or interacts with things with charge. So if you have young, healthy, thick, plush skin, you've got a lot of collagen fibre right below the surface, and that collagen fibre is charged and it can hold water molecules onto it. As we age, that particular process gets less and less good, because we start losing our collagen. We don't have as much, our skin isn't as thick as it used to be. We don't replace the collagen fibres that wear out as well. So we, over time, gradually lose our ability to hold water in our skin. And for women, that's after the menopause. The skin thins out quite quickly after that. For men, it's a gradual process all the way through life. But by the time both sexes reach their 70s, the thickness of the skin of a man or a woman is roughly about the same. Why is that important to know? Well, the older we are, the more hydrated we need to stay, because we can literally lose water off the skin by evaporation. And if we're not able to hold it there from the collagen, then the loose water, if you like, will just leave and be lost, and therefore we're actually dehydrating through our skin. So higher levels of hydration are beneficial to older people, as long as their kidneys can take it. Temperature control. This one shouldn't be too complicated. We know very quickly after starting exercise that we start to get hot and we start to sweat. This is because when we use energy to cause muscles to shorten, only about 40% of the energy that's released goes to the shortening of the muscle. The other 60% is actually released as heat in the muscle, and as the blood passes through the muscle, taking oxygen and nutrient to it and taking away wastes, it also gets heated up by this increasing heat in the muscle area. And so the blood then travels around the rest of the body and heating up the whole body. And as we heat up, our hypothalamus picks that up in our brain and it opens up the blood vessels close to the surface of our skin, so we start going red or pinkish colour, and then we start to sweat. That's the sweat glands taking the warm liquid and leaving it onto the surface of the skin and allowing it to evaporate off. Now that's not pure water that we're losing salts or electrolytes in that, and we're actually even losing urea, which is also made in the liver and excreted in the kidneys, so it has to travel in the blood to get there. So we even actually have urea sitting on the surface of our skin, which drops the pH to about 6 and actually creates what we call an acid mantle, which actually adds to the protection factor because bacteria don't really like acid conditions to live in, so it reduces their number. So that's temperature control or sweating. The final one I've got on here, and this is a very short list, there's lots of other things that skin does for us, is the production of vitamin D. Now vitamin D is important because it's involved, or you have to have enough of it along with magnesium to help uptake of calcium in the gut. And calcium, as you probably know, is important for strong bones. But believe it or not, when we talk about the bones, calcium is really just stored in the bones, and if required for physiological purposes such as muscle contraction or nerve conduction, is taken out of the bone. So to have strong bones, we need to have enough calcium to do all of our physiology, plus extra to go into our bones. Vitamin D helps us do that, and when we're exposed to UV light, the second of the three processes that take place, helps to convert the precursor into the vitamin D. And that means that 10-15 minutes of good quality UV sunlight usually helps to produce enough vitamin D for each day, during the summer months anyway. Now I'm not going to get dragged into what happens at winter. Alright, so these are our properties. Let's start thinking. We've got an outer layer of epidermis, we've got an inner layer of dermis. So what do we actually find in these layers? Well, in the dermal layer we've got the skin surface, and then we've got the dermal surface there, and we've got layers of cells in between. So down here we have a layer of cells sitting at the junction between the dermis and the epidermis. Now of course all these cells have nuclei. They all look a bit cuboidal, don't they? Okay, so this is the start of the epidermis, moving to this is the outside. So this layer is actually a very important layer. All the layers we have are called strata. Strata is Latin for layer. So each layer is like strata basale, strata spinosa, the layer of, and then the basale and spinosa just explain what type of cells and what they're doing there. Now essentially in the epidermis we have two types of cell. We have keratinocytes and melanocytes. These are our two main cell types. Now, cyte equals cell in Latin. So the front part of the word, keratin, melano, tells you what type of cell it is. So the keratinocytes are cells that contain keratin. Keratin is a hard protein which forms the strength of our nails, and difficult for me to do this, maybe come down here, and our hair. So both the nail tissue, the hair tissue, once it's come through the skin, is dead cells, but it's made up of cells thick with keratin protein. So the cells in our skin also on the surface have keratin in them, so they are called keratinocytes, or cells that contain keratin. This again makes it very hard for pathogens to really do much with it. Keratin is very hard to break down. It's not really available to the bacterium or the virus or the fungi, whatever happens to be trying to break through. So we have these cell types. So the vast majority of these cells from here all the way to here are keratinocytes. In amongst that we have melanocytes. Every so often. And melanocytes are kind of spidery-like cells. They have the cell and then they have these kind of tendrils that come out of them and move up into the layer above. Now, this layer here, single set of cells, is, I'm just going to put S for strata basale, or the basal layer. In some textbooks you'll see it referred to as germinativum, because it's the germinating layer. And why would it be the germinating layer? Well, if you remember, this is epithelia, and epithelia is avascular, meaning it doesn't have a blood supply. So the cells closest to the blood supply, which is in the dermis, which is connective tissue, so the blood supply is running about there. So it's feeding these cells and keeping them alive and healthy. Now that's a really good thing, because the stratum basale, or the deepest of the epidermal layers, is where all of the rest of the epidermal cells come from. It's where they're born. Hence the older name germinativum, the germinating layer. We now call it the stratum basale because it's the basal layer, it's the bottom layer. So these cells are able to divide, and when they do, they split into two. So this one cell becomes two. That's the new cell stays there, and it pushes the new cell up one. So every time it divides, it pushes another cell up. And gradually, over time, a cell born here eventually ends up here. Now that process takes roughly about 6 weeks, 4 to 6 weeks, for a cell born here on the stratum basale to reach the outer surface and be sloughed off. As it goes through this process, this is a keratinocyte, it goes through changes, and the changes are essentially documented by the changing in the way that we call the layers. So this first layer is stratum basale. Excuse me. The next layer above it, here, is stratum spinosa. Now spinosa essentially just means spiny. So these cells here are pointed. They're sharp looking, and hence the name spinosa for spiny. Now these are still relatively healthy cells, they're still quite close to the blood supply, so they're still functional. As we push up through the spiny layer, we reach the next layer, which we'll put here, and this is sorry, that's not written very well, but you'll get it in your text anyway, is granulosum. Now when the cells push up through here, they're getting a bit flattened out by this point, they're getting a bit squashed down, because remember this all is stratified squamous, meaning it's all squashed down. The lower layer looks more cuboidal because it's not been fully squashed. So you're getting cells here flattened out. But the other thing that we notice at this stage, in the granulosum layer, is inside the cells you can see granules. So we've got 3 layers so far. We've got basale, the basal layer, where everything is born. So that's done through mitosis. The spiny layer, or spinosa, where the cells that are born pushed up have this kind of angled sharpness to them, hence the name, because it just describes as to see under the microscope. And then the next layer up is granulosum, or the grainy layer, because the cells are flattened out and they've got granules in them. Now, by the time you reach stratum granulosum, you really have got relatively far away from the blood supply at this point. So the cell is getting into trouble. It's no longer really able to keep itself alive. It's breaking down. And so these grains that you're seeing in the microscope is the breakdown products of the organelles and everything as the cell dies. And the last thing the cell does as it gets into trouble is it starts to produce lots and lots and lots of the protein keratin. So basically eventually becomes a small bag, flattened bag of keratin protein. So when we get up to this layer, the cells are dying off, you're getting the dots appearing because this is the breakdown of the cell and the appearance of the keratin. In the final layer, the cells are increasingly squashed down and they are just full now of keratin. And so this layer, let's put it here, is stratum corneum, or the horny layer. Now, keratin is that makes our nails and our hair, also makes the horns of goats and rams, cattle. So that's why it's called the horny layer. It's the same stuff. So the cells that reach this point have lost the granular look. They're now just full of keratin. So they're flattened out, full of keratin, and they are dead. And this is the top layer, which we see when we look down on the skin, and it gets gradually sloughed off. Now that's about 90%, 95% of our body has these 4 layers. In your textbooks and in the lecture you'll see that there are 5 layers in some parts of the body, and this is called the thick skin. So the palms of our hands and soles of our feet are thick skin. And this means that there is an extra layer between granulosum and corneum. And this layer, which I'm going to do in green, this layer is called lucidum, stratum lucidum, the clear layer. And it's just a buffer layer before we get to corneum and thick skin, but if you notice the layer before that's granular, this layer is clear. The granules have all gone away and it's just finishing or filling with keratin. So in thick skin, the palms of our hands, soles of our feet, we have the 5 layers. Basale, spinosa, granulosum, lucidum, corneum. To this day, I've always remembered them the opposite way around, because when I was learning it, I took the first 3 letters of each one and made myself a very stupid phrase, which fortunately just stuck in my head. So I always think core, look, gran, spinning, bass. Doesn't really make a great deal of sense, but I've always remembered it. Anyway, so these are the 5 layers. They're all keratinocytes, starting from the base, moving up to the surface. Really, kind of the last couple of things I want to say about this in terms of the epidermis is going back to these melanocytes. The melanocytes are stimulated by UV radiation. So it penetrates down through the layers and it stimulates the melanocytes to start producing melanin, which is the dark pigment. Now, depending on our genetics, we have melanin, but we'll have different levels of depth of pigmentation. So people with darker skin colour produce the darker pigment naturally. People with lighter skin colour, they produce a lighter pigment, so it's not as effective under high UV radiation. So the melanin is the melanocyte is stimulated to produce melanin. Now it doesn't just store it in that cell. If it stored it here, 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 and here, and here, it's not going to really protect very much. So what it does is it leaks it out of its tendrils. So it starts to leak all the way out here. So basically along here. It's picked up by the keratinocytes in the spinosa layer. And so all of those cells then start holding pigment in them. What this does is it creates an umbrella effect which helps to absorb and reflect back the UV light. Why is that important? It is important because these cells are doing mitosis, they're dividing. Now, as I tried to say on the mitosis, when you've got a cell, it's got a cell membrane, it's got a nuclear membrane, and the DNA inside is supercoiled, wrapped up on itself. It's really, really, really well protected. So any UV light coming into this isn't going to have a great deal of effect on the DNA inside. However, if you then compare that with a cell which is dividing, it's lost its nuclear membrane, the supercoiling of the DNA has gone away, it's now opened up and exposed the DNA completely, so the UV light now, when it penetrates through the cell membrane, is hitting the chromosomes and the DNA that make them up directly. And that, over time, can cause mutations or changes, and therefore causing damage to the chromosomes in this layer. So the melanocytes are being stimulated to produce an umbrella effect to prevent damage taking place to the cells below, which are undergoing mitosis and are vulnerable to DNA mutation because of that. That leads us to talk a little bit about skin cancer. There are 3 main types of skin cancer. There is basal cell. Now you've just heard stratum basale. So basal cell carcinoma is a cancer of the keratinocytes on the basal layer. So just when I got finished saying the UV light has caused damage to the cells dividing, it's interfered with their cell cycle, and they are now, I'll put it over here, they are now growing uncontrollably. The fortunate thing about basal cell carcinoma is it tends to grow up and outwards. So it comes off the basal layer and comes out, breaks through the surface of the skin, and is seen as a fairly unusual lump on the surface of the skin. As soon as that's diagnosed, it's removed, and generally speaking, that's the end of the story with basal cell. So it occurs to the stratum basale because UV light has damaged the cells while they were dividing. The next one we can think about is squamous cell carcinoma. And that occurs higher up. And remember, this all is stratified squamous. Once this gets going, it'll grow up and ulcerate, but it can also grow down. The danger of that is it reaches the blood vessels here. Once cancer cells go into blood vessels, they can travel to other parts of the body. The same is true if they get into the lymphatic system. And finally, we have melanoma. Melanoma, as you might now understand, is cancer directly affecting the melanocyte, which is producing the pigment. Now, these usually give you a little bit of warning, because on the surface where the pigment is, if you've got like an area there, you've got a fairly uniform and well documented or well prescribed area. So if you're looking from top down, it's a very, very clear outline and it's very uniform colour. That's a normal mole. If this mole suddenly starts to get bigger and then starts to have a very rough, fuzzy outline and starts to have patchy colour, variable colour all the way through it, these are all signs that that might be a melanoma starting. Anytime you see the presence of a new mole in someone over the age of 15, a mole which has this kind of weird fuzzy edges, it's raised, so if you look at it side on, it's raised off the skin, it's got patchy colouring, it's raised off the skin, it doesn't have a clear border to it, and it's new or it's growing. Any one of those signs, you should immediately seek medical attention, because that could be a melanoma. Melanomas, because they're right here, don't have to grow very, very large before they grow down into the blood supply. This is why melanoma is the more dangerous of the skin cancers, because it can quickly access the blood supply if we're not paying attention. One of the problems for us, particularly in places like Michigan here in the summer, a lot of people walk around, little guys walk around without their tops on to get a good tan, etc. So guys tend to actually get these on their backs, and so most men don't spend a lot of time staring at their back. It's up to other people to spot or notice that the moles have appeared or beginning to change or grow, whichever, so they can go in and get treated. Legs are another one for men, but you should try and have a check at least once a year for this. Catch it early, it's fine. Catch it late, then it gets a lot more complicated, and I would rather you didn't have to do that. So these are the skin cancers. Hopefully by explaining the epidermis and the keratinocytes and the melanocytes and the layers, you now have a basic understanding of what they are and why they're dangerous. Alright, I'm going to stop there, and in the second one we're going to come back and we're going to think about the dermal layer which sits below it.